So in today's lecture, we are going to talk about the static characteristics of the instruments, and also we are going to discuss that what is the meaning of calibration. What do we actually mean? This is a very popular term that we keep hearing now and then when it comes to measuring devices, that is called calibration. Okay, so we are going to see what actually calibration means and what are the basic characteristics that an instrument should have so as to give us an appropriate reading. Now the characteristics of the instruments, actually they are divided into two parts. Okay, two types of characteristics we have. One is the static characteristic and another one is the dynamic characteristics. So in this particular session, we are going to talk about the static characteristics of the instrument. Okay, so the performance characteristics of any instrument can be divided basically into two categories, static and dynamic. Now, some applications, they involve the measurements which are either constant or varying very slowly with time. Okay, so the set of criteria that is defined for the instruments which are used to measure the quantities that are slow varying with time or mostly constant is called the static characteristic. तो जब तो ऐसा होता है कि हमारा जो मेजरेंट है, यानी कि वो क्वांटिटी जो हमें मेजर करनी है, या तो वो कांस्टेंट है या वो बहुत ही स्लोली वेरी करता है, तो उस केस में जो इंपॉर्टेंट कैरेक्टरिस्टिक्स हमारे इंस्ट्रूमेंट में, हमारे मेजरिंग डिवाइस में होने चाहिए, उन्हें हम कहते हैं स्टैटिक कैरेक्टरिस्टिक्स. फॉर एग्जांपल, यू हैव टू मेजर डिस्टेंस. ओके, आपके पास सपोज यू हैव अ पीस ऑफ पेपर एंड यू वांट टू फाइंड आउट व्हाट इज द लेंथ ऑफ द पेपर. नाउ लेंथ ऑफ दैट पेपर इज अ कांस्टेंट वैल्यू. It is not varying with time. Okay, it is not fast varying with time. So what you need to have is you need to have a scale. Now for that scale to actually give you an appropriate reading, or that scale to give you an exact value of the length, you need to have some important characteristics in that scale जिन्हें हम static characteristics कहते हैं. At the same time, suppose you have an accelerometer. That means you have a fast moving vehicle जिसकी speed या जिसका acceleration आपको measure करना है. Now acceleration or speed is actually a fast changing quantity which you have to measure. In that case, whatever measuring system you are going to design, the most important characteristics that should be there in the system, in your measuring system, they are termed as डायनामिक कैरेक्टरिस्टिक्स. बिकॉज हमारा, अगर आप एक्सेलरेशन मेजर कर रहे हो या स्पीड मेजर कर रहे हो या वेलोसिटी मेजर कर रहे हो, दीज आर फास्ट चेंजिंग प्रॉपर्टीज. तो उस केस में हमारे सिस्टम के अंदर जो इंपॉर्टेंट कैरेक्टरिस्टिक्स होने चाहिए वो डायनामिक कैरेक्टरिस्टिक्स होते हैं, जहां पर आप किसी ऐसी क्वांटिटी को मेजर कर रहे हो जो या तो कांस्टेंट है या स्लो मूविंग है, जैसे कि लेंथ. ठीक है, सो इस केस में आपके डिवाइस में जो इंपॉर्टेंट कैरेक्टरिस्टिक्स होने चाहिए उसे हम स्टैटिक कैरेक्टरिस्टिक्स कहते हैं. ओके, ऑफ कोर्स मोस्ट ऑफ द डिवाइसेस हैव बोथ स्टैटिक एज वेल एज डायनामिक कैरेक्टरिस्टिक्स, बट what is to be of importance, that actually depends upon what kind of measurement you are going to measure. That on that basis we actually see that what characteristics we have to consider. Okay, so on that basis we actually divide the basic characteristics of an instrument into two categories, that is static and dynamic. Now one by one we are going to talk about the basic static characteristics that should be there in your system. So abhi hum isme se bahut sare terms hain which you keep on hearing on and off. Okay, but we are going to see that what is the actual definition and the meaning of all these terms that we keep hearing, okay, with respect to any measuring system. Okay, so we are going to talk about the various static characteristics that should be there in the system when you are having a measuring instrumentation system. So the first one we are going to talk about is accuracy. Again, very common, very popular. We keep hearing accuracy off and on all the time. What does it mean? Accuracy means the closeness with which the measuring instrument can measure the true value of the measurement under stated conditions of use, that is its ability to tell the truth. Okay, in reality, if the temperature is suppose 40 degrees, then the capability of the instrument to give you the reading as close as possible of 40 degrees is actually accuracy. That means the capability of the instrument or the closeness of the reading that the measuring instrument is giving to the true value. True value मतलब जो actually में है, कितना टेम्परेचर है या कितनी लेंथ एक्चुअली में है और आपका डिवाइस कितनी दिखा रहा है. So if your measured value is closest or as close as possible to the actual value, we say that this device or the system is very accurate. The accuracy of an instrument is quantified by the difference in its readings and the one given by the ultimate or the primary standard. Now, accuracy measure करने का सिर्फ एक ही तरीका होता है, that you measure it with your device and then you measure the same quantity with some standard device. Okay, with some calibration device or with some standard identified primary standard. तो उससे हम मेजर करके कंपैरिजन की हेल्प से फाइंड आउट कर सकते हैं कि हमारा जो सिस्टम है वो कितना एक्यूरेट है. Accuracy depends on on inherent limitations of instrument and shortcomings in the measurement process. Okay, so now there are certain terms which are very close to each other related to accuracy. Let us see what these are. How we represent accuracy is percentage of true value, that is measured value minus true value multiplied by 100 divided by true value, or we can also represent it percentage of full scale deflection, that is measured value minus true value divided by the maximum possible value and into 100. So these are the two ways in which you can actually represent accuracy. For example, if you have a 100 psi gauge with 0.1% of full scale accuracy, okay, would be accurate to plus minus 0.1 psi across its entire range. So if I am having a gauge, okay, which has a complete range of 100 psi, that means from 0 to 100 psi pressure it can actually measure, and we say that it has a full scale accuracy of 0.1%. that means that entire range के लिए उस particular gauge में plus minus 0.1 psi का error हो सकता है. ठीक है, आप उसमें चाहे प्रेशर 1 हो, 10 हो, 90 हो, 40 हो, कोई भी रीडिंग लोगे from 0 to 100, there will be an error, there might be an error of plus minus 0.1%. Okay, so that is there will be an error of 0.1 psi. So that is called 0.1% of full scale accuracy. By convention, a gauge specified as 0.1 accuracy is implied to be 0.1% full scale. So in general, if you're not using any other term and you say 0.1% accuracy, it by default means full scale accuracy. When manufacturers, they define their accuracy as percentage of reading, they are describing the accuracy as the percentage of the reading currently being displayed. For example, a gauge of 0.1% of reading accuracy that displays a reading of 100 psi would be accurate to plus minus 0.1 psi at that pressure. At 50 psi, the same gauge would have an accuracy of plus minus 0.05 psi. So basically, there are two ways. आपके पास एक 0 से 100 psi range का एक gauge है for measuring the pressure, और आप उसकी accuracy दो तरीके से बता सकते हो. अगर आप कहते हो 0.1% of full scale accuracy, तो 0.1% of full scale हुआ, full scale is 100 psi, 0.1% is 0.1. So that means entire range from 0 to 100, कोई भी वैल्यू होगी मेजरमेंट की, उसकी एक्यूरेसी में प्लस माइनस 0.1 का ही एरर हो सकता है. इससे ज्यादा एरर किसी भी रीडिंग में नहीं होगा. अब हमने क्या कहा, दूसरा तरीका है इसको एक्सप्लेन करने का, that we are explaining the accuracy in percentage of reading. So percentage of reading का मतलब ये हुआ, अगर हमने कहा 0.1% when the reading is 100 psi. Okay, so when I am saying that 0.1% accuracy when the reading is 100 psi, तो वो जब 100 psi शो करेगा तब प्लस माइनस 0.1 psi will be the error, but when it is going to be 50 psi, the same gauge would have plus minus 0.05 psi. कहने का मतलब ये है that the when we are defining it in terms of percentage of reading, so percentage of reading का मतलब ये हुआ that it can change as the reading is changing. उसकी accuracy 50 psi measurement पर कुछ और होगी और 100 psi पर कुछ और होगी, 90 psi पर कुछ और होगी. So then that is another way of describing the accuracy. One is percentage of full scale accuracy and one is percentage of reading accuracy. Then another thing very similar to accuracy we have is precision. Precision is defined as the stability of the instrument, the ability of the instrument to reproduce a certain set of readings within a given accuracy. Okay, precision describes an instrument's degree of random variations in its output when measuring a constant quantity. Now, accuracy तो हो गया कि actual जो value है उसके close कितना है value, okay, towards the true value. Precision का मतलब है कि same set of readings को reproduce करने की ability कितनी है इंस्ट्रूमेंट में. अगर आपने 10 बार रीडिंग ली, क्या 10 बार उसने सेम वैल्यू दिखाई? Of course, under a given condition, under the same given conditions. Okay, if you are using multiple times the same instrument under the same given conditions for the same measurement, is it capable enough to give you the same reading all the time? Okay, that reading might be accurate, might not be accurate. Accuracy और precision दो अलग-अलग चीजें हैं. Accuracy का मतलब होता है closest towards the true value. Precision का मतलब होता है multiple readings being close to each other. They might be near to the true value, they might not be near to the true value. हो सकता है कि आपका जो actual value है वो है suppose 100 psi, but what is happening? Your device is not very accurate. What it does, it measures 90 psi. Okay, but when you measure the same quantity 10 times, every time it is giving you 90 psi. That means what? Your instrument is not accurate, but your instrument is precise. It has precision because again and again when you are measuring the same quantity, it is giving you the same value, but it is away from the true value. 100 की जगह वो 90 दिखा रहा है. That means it is not accurate. Okay, so this is the difference between accuracy and precision. Precision is basically a degree of repeatability. Okay. So precision actually depends upon the repeatability of the instrument. Precision is often confused with accuracy. High precision does not imply about anything about the measurement accuracy. This I have just now explained to you that precision and accuracy are two different things. Precision just means repeated measurement giving you the same value, and accuracy means your value should be very close or closest possible to the accurate or you can say the true value. So with this particular figure, this is the best way of explaining accuracy and precision. First figure that you see, the dot in between is your true value. That means that is the target which you want to measure. Now हमने तीन अलग-अलग instruments से measurement लिया, and first case में क्या हुआ that you get all the scattered readings. There is no reading at the true value, and all these we have 7 readings. All 7 readings are scattered. That means no precision and no accuracy. कोई भी reading true value के पास नहीं है, no accuracy. कोई भी reading एक दूसरे के आसपास भी नहीं है, no precision. So this first figure that you see is indicating low precision and low accuracy of the instrument. Then coming to the second figure over here, you can see a cluster of values close to each other but away from the actual value. So this device has high precision because repeatability is there, but it has a very low accuracy because that repeated values that you are getting is very far away from the true value. So this is high precision but low accuracy. And the third figure that you see, you get repeated values same and at the same time very, very close or almost on to the true value. So this indicates high precision and high accuracy. Iska matlab, the value is very accurate, accurate meaning to say very close to the true value, and at the same time, if you repeat the same measurement 10 times, 20 times, or 50 times, it will give you the same reading every time you measure. So this is high precision and high accuracy. Then we have resolution and threshold. Resolution is the minimum change or the smallest increment in the measurement value that can be detected with certainty by the instrument. It can be the least count of the instrument. So जैसे कि सबसे छोटा unit आपका instrument क्या measure कर सकता है, that is the resolution. It might be 1 millivolt, it might be 1 volt, something like that. So the smallest possible change that or the smallest possible unit of change that your instrument can measure is actually called the resolution. This can also be called as the least count of the instrument. Then we have threshold. Threshold is defined as the range of different input values for which there is no change in the output value in the beginning. So meaning to say कि threshold value जब तक कि input पर achieve नहीं होगी, वो device active ही नहीं होगा. For example, suppose you have a motor. Now, every motor has certain basic value of voltage which has to be given to it. Only then it starts working. If your motor value की rating जो है वो 5 volts है और आप उसमें 2 volts की बैटरी लगाओगे, motor doesn't work. That means 5 volts is the threshold value जिसके बाद वो device active होगा. और जो भी accuracy, precision, resolution जो कुछ हम पढ़ रहे हैं उस रीडिंग के बाद वो फॉलो करना स्टार्ट करेगा. There is no reading below that scale. ओके सो कोई भी अगर आपका मान लीजिए आपका मोटर भी है, आप 5 वोल्ट से कम कुछ भी उसमें वैल्यू लगाओगे, द मोटर इज नॉट गोइंग टू स्टार्ट रोटेटिंग. दैट मींस बिलो द थ्रेशोल्ड वैल्यू देयर विल बी नो आउटपुट. If the input value is below that particular value, there will be no output. Output जैसे मोटर के केस में output is the rotational speed. तो जब तक कि आप minimum 5 volt नहीं लगाओगे, तब तक output पर there will be zero rotation. That means motor doesn't get activated. So that is the concept of threshold. That means below that particular value, whatever changes you go on making, आप 3 से 4 कर दो, 4 से 4.4 कर दो, 3 से 3.5 कर दो, कोई भी changes करोगे below 5 volts, motor doesn't work. So threshold value से नीचे की values में आप कोई भी changes लाओगे, the output will still remain zero. So that particular value at which the instrument gets activated and it starts measuring some value or it starts giving some output, that is defined as the threshold. The next quantities, the next characteristics that are of importance are range and span. Range is the range of the instrument defines the maximum value of the quantity that the instrument is designed to measure, whereas the span of the instrument defines the minimum and maximum values of the quantity that the instrument is designed to measure. For example, अगर मैंने कहा range only tells me the highest value. अगर मैंने कहा 100 psi, so 100 psi is the range, maximum value that it can measure. But उसका span कितना होगा, वो डिपेंड करेगा कि मिनिमम वैल्यू वो कितनी डिटेक्ट कर सकता है. सपोज उस गेज का थ्रेशोल्ड ही 50 psi है कि 50 psi से कम वैल्यू पर वो एक्टिव ही नहीं होता है. ठीक है, सो स्पैन विल बी फ्रॉम 50 to 100 psi, but the range would be 100 psi. So when I say range, it defines the maximum value that your instrument can actually measure, and when I say span, it means minimum and maximum, both the values which the instrument is designed to measure. That is a slight difference between these two characteristics. Then we have sensitivity. Sensitivity of an instrument is the change of the output divided by the change in the measurement. As an example, consider the pressure sensor that has a measurement range of 0 to 100 psi and an output range of 0 to 5 volts. So the sensitivity will be 0.05 volts per psi. So basically this is when you're finding out the sensitivity, it means, you know, how much for a small range of, for a small change in your input, the output can actually show some deflection. So this actually we find out by the output divided by the change in the input. For example, आपके पास अगर pressure gauge है, उसके input पे हमारे पास pressure होता है और output पर voltage होती है. जो input है उसकी possible range जो है वो 0 से 100 psi है. ओके, उस गेज को हम 0 से 100 psi का प्रेशर देते हैं, तो हमारा आउटपुट 0 से 5 वोल्ट्स के बीच में कुछ शो करेगा. So उस केस में सेंसिटिविटी कितनी हुई? That is going to be 0 to 5 volts divided by 0 to 100. So that will give you 0.05 volts per PSI. इसका मतलब अगर 1 PSI का चेंज इनपुट में होगा तो 0.05 volts का चेंज आउटपुट में रिफ्लेक्ट होगा. Once again, I am saying sensitivity means the change in the output, possible change in the output divided by the change in the input. Now here if I have a gauge जिसका इनपुट जो है वो रेंज करता है 0 से 100 psi and आउटपुट जो रेंज करती है वो है 0 से 5 volts. In that case, the change in the input output, that is 5 volts, divided by the change in input, that is 100 psi, gives you 0.05 volts per psi. This indicates that if there is a change of 1 psi, there will be a change of 0.05 volts at the output. So it can be defined as the ratio of incremental output and the incremental input. While defining the sensitivity, we assume that the input-output characteristic of the instrument is approximately linear in that range. Okay, so linearity simply we assume that input and output जो है वो आपस में एक linear relation follow कर रहे हैं. When I say linear relation, mathematically it means y is equal to mx. यानी आपस में कोई proportional relation होता है in that instrument between input and output. That is the simple meaning of linearity. Then we have hysteresis. Hysteresis exists not only in magnetic circuits, but in instruments also. For example, the deflection of a diaphragm type pressure gauge may be different for the same pressure, but one for increasing and other for decreasing order. Now, for example, आपके पास एक diaphragm type का pressure gauge है. Diaphragm क्या होता है? एक flexible surface होती है जिसके ऊपर जब आप pressure apply करते हो तो वो deflect हो जाती है. Okay, so अगर हमारे पास एक diaphragm type का pressure gauge है, हमने क्या किया? हमने उसके ऊपर प्रेशर पहले इंक्रीजिंग ऑर्डर में लगाया, फिर डिक्रीजिंग ऑर्डर में लगाया. यानी पहले हमने 10 psi लगाया, फिर 20 लगाया, 30 लगाया, 40 लगाया, वो स्ट्रेच होता जा रहा है आपका डायफ्राम. अब हमने क्या 50 तक हमने अप्लाई किया. सो यू विल गेट सम रीडिंग्स. ओके, फॉर एग्जांपल सम वैल्यू यू विल गेट. नाउ व्हाट हैपेंस इज जब आप उसको वापस रिड्यूस करोगे, When I am saying अगर मैं उसको रिवर्स ऑर्डर में लगाती हूं, यानी कि अब मैं 50, 40, 30, 20, 1 करूंगी, the same values for the corresponding input will not get repeated. Okay, for example, if you see this graph over here, from output your readings are going to y axis पे हमारे पास output है, x axis पर हमारे पास इनपुट है. जब मैंने इनपुट को आई मिनिमम से आई मैक्सिमम पे इंक्रीज किया तो जो मेरे को आउटपुट का ग्राफ मिला था वो सी दिस अपवर्ड एरो. दैट मींस आई गॉट सर्टेन सेट ऑफ रीडिंग्स व्हेन आई वाज इंक्रीजिंग द इनपुट फ्रॉम आई मिनिमम टू आई मैक्सिमम. नाउ व्हेन आई स्टार्ट रिड्यूसिंग फ्रॉम आई मैक्सिमम बैक टू आई मिनिमम, आई एम रिड्यूसिंग द इनपुट बैक. द कर्व दैट माय सेंसर इज ट्रेसिंग is this one where you can see the backward arrow. So वो एक देखो दो रीडिंग at the same time, दो आउटपुट सेम आउटपुट को वो दो बार लेगा, but always it is for the different input values. अगर if you see very closely the tip of this arrow, suppose this corresponds to some output value x. Once again I am saying suppose this tip actually corresponds to some value x on this vertical axis. So this value x on the output comes twice. अगर if I extend this line, तो एक बार ये इस वाले ग्राफ पे आएगा और एक बार rising ग्राफ पर भी आएगा, that value x. But when it was the rising graph, it corresponds to a different input, and when it comes on the falling graph, it corresponds to another different input. So this is called hysteresis. That means there is no homogeneity between the input and the output when you are increasing the input and when you are decreasing the input. Same value for the same input you don't get. Okay, once again I'll tell you that when you have a sensor, you apply some input in the increasing order. It will show some behavior which you can see from here with the arrow going upwards. Now when the same input you start reducing from maximum to minimum, same set of readings you are applying, but in the reverse order, in the decreasing order, the graph that you see that your sensor is tracing is coming from downwards. The arrow that you see over here coming down. So these two graphs are totally different in behavior. Okay, that means suppose same value of I, अगर यहां पर कोई एक वैल्यू 50 था इनपुट का, जब आप इसको इंक्रीजिंग ऑर्डर में अप्लाई करते हो तब वैल्यू आउटपुट की कुछ और आएगी, और जब आप उसको डिक्रीजिंग ऑर्डर में अप्लाई करोगे तब वैल्यू कुछ और आएगी. दिस फिनोमेना इज कॉल्ड hysteresis. This is an unwanted phenomena. It should not be there in your devices. Device should be very much precise and accurate for increasing as well as the decreasing value of inputs. And this usually happens with the regular wear and tear that comes into picture. जब किसी डिवाइस की इलास्टिसिटी खराब होने लग जाती है तब इस तरीके की प्रॉब्लम आती है, that when you increase, go on increasing the load, वो stretch तो हो गया, but its restoring capacity with time has reduced, so it is not able to come back to the original position. जैसे डायफ्राम की फ्लेक्सिबिलिटी हो सकती है, स्प्रिंग का बाउंस हो सकता है. अगर स्प्रिंग जैसे जैसे पुराना होता चला जाता है उसकी बाउंस बैक कैपेबिलिटी रिड्यूस हो जाती है. तो उस केस में क्या है, जब आप उसके ऊपर कोई वेट लटकाओगे, व्हेन यू गो ऑन इंक्रीजिंग द वेट it does stretch down. Okay, but when you go on decreasing the weight, it might not be capable enough to come back to the same original position very quickly. Okay, so that is basically hysteresis, which is an unwanted phenomena. It should not be there in your devices or in your sensors. Then we have backlash. This actually comes into picture when you are talking about the mechanical gears. Okay, now so over here if you see, it is defined as the maximum distance or the angle through which any part of mechanical system may be moved in one direction without causing motion in the next part. अब इस gear system को आप लोग ध्यान से देखिए. One teeth of the driven gear. Firstly, I have two gears. One is called the driven gear. Another one is called the driving gear. Driven gear का एक teeth ड्राइविंग गियर के दो टीथ के बीच में हमने लॉक कर रखा है. नाउ इफ यू सी दिस वेरी वेरी केयरफुली, जब मैं इसको किसी इफ यू सी दिस डायरेक्शन जिसमें एरो बना हुआ है, दैट इज एंटी क्लॉकवाइज डायरेक्शन. अगर मैं ड्राइविंग गियर को एंटी क्लॉकवाइज डायरेक्शन में घुमाना शुरू करूंगी, ओके, अगर मैं ड्राइविंग गियर को एंटी क्लॉकवाइज डायरेक्शन में घुमाना शुरू करूंगी तो क्या होगा, ये जो बीच में जो गियर लगा हुआ है, this teeth of the driving gear, please see the pointer that I'm showing, this teeth above the in the driving gear, ये तब तक driven gear को ड्राइव नहीं करेगा जब तक कि ये इसके कांटेक्ट में नहीं आता. यानी कि जब तक मैं ड्राइविंग गियर को चलाऊंगी वो थोड़ा सा ये शॉर्ट डिस्टेंस कवर करके पहले ड्रिवन गियर की टीथ को टच करेगा और फिर इसको ड्राइव करना शुरू करेगा. इसका मतलब एक छोटा सा डिफरेंस है यहाँ पर, थोड़े से डिस्टेंस के लिए. जब तक मैं सपोज मे बी 1 डिग्री ओनली, जब मैं उस 1 डिग्री के लिए इस ड्राइविंग गियर को घुमाती हूं तो मेरा ड्रिवन गियर नहीं घूमेगा. ठीक है, और उसके बाद जब ये दोनों टीथ आपस में कांटेक्ट में आएंगे तब मेरा ड्राइविंग गियर जो है वो ड्रिवन गियर को चलाना शुरू करेगा. एंड नाउ दे बोथ द गियर्स दे गो ऑन मूविंग विद कोऑर्डिनेशन. अब क्या होता है, in between I want to reverse the direction of my gears. So what I will do, I will stop the gear. I want to reverse the direction of my driving gear. Now see the teeth below, this below, wherever I am pointing my arrow, this teeth that is below, जब मैं इसको clockwise घुमाने की कोशिश करूंगी, again there is some distance maybe of 3 degrees or 4 degrees in between, जब ये दोनों teeth आपस में contact में नहीं आ रहे हैं. When they are not coming in contact, this 3 or 4 degrees, when I drive my driving gear, the driven gear does not move. जब ये थोड़ा सा 2-3 degrees move करके driven gear के teeth को touch करेगा, उसके बाद मेरा driving gear driven gear को चलाना शुरू करेगा. So both ways, जब भी मैं इसकी डायरेक्शन चेंज करती हूँ तो बीच में 2-3 डिग्री का जो ये गैप है, इसकी वजह से एक कुछ पर्टिकुलर वैल्यूज ऑफ इनपुट ऐसी आएंगी जब मेरे पास कोई आउटपुट नहीं होगा. ओके, दैट इज कॉल्ड बैकलैश. यानी कि जब मैं डायरेक्शन ड्राइविंग गियर का चेंज करती हूं तो ड्रिवन गियर का डायरेक्शन अपने आप इंस्टेंटली चेंज नहीं होता है, वो 2-3 डिग्री का गैप रहेगा। जब वो 2-3 डिग्री का गैप मेरा ड्राइविंग गियर कवर अप कर लेगा और ड्रिवन गियर के टीथ के साथ डायरेक्ट कांटेक्ट में आएगा, तब मेरा ड्रिवन गियर अपनी डायरेक्शन चेंज करेगा। सो इसका मतलब इन दीज टू देयर विल बी अ स्मॉल गैप ऑफ maybe 2-3 degrees. Maybe that takes suppose 5 milliseconds it is taking. So for that particular 5 milliseconds जो मेरा ड्रिवन गियर है वो अपनी ओरिजिनल वैल्यू पर ही चलता रहेगा, और ड्राइविंग गियर ऑल्दो मैंने घुमा दिया है बट द ड्रिवन गियर डज नॉट मूव. Okay, so this kind of this is called property, you can say. This is called backlash. It appears only, this is specific only to mechanical components. और इसको कवर अप करने का एक ही तरीका होता है, that make your mechanical components as close as possible, fixing with each other. ये गैप को हम जितना कम करेंगे उतना बेटर हमारे पास परफॉर्मेंस होगा. So backlash is basically when the mechanical system is used, or you can say when the gear arrangement is used. In the gear arrangement, whenever you want to change the direction of the gears, हम ड्राइविंग गियर की डायरेक्शन जब चेंज करते हैं तो ड्रिवन गियर की डायरेक्शन इंस्टेंटली चेंज नहीं होती, बिकॉज इन बिटवीन दीज टीथ there is a gap of about 3 to 4 degrees, suppose, very small gap. So by the time this driving gear covers this gap, the driven gear does not change the direction. Once this gap gets covered, the two teeth come in close contact with each other, then the opposite force works on the driven gear and the direction of the driven gear actually changes. So this kind of a phenomena is called backlash. Again, this is an unwanted phenomena. This should not be there, and this can be reduced by designing your mechanical components as properly as possible by having no distances in between. So this is called backlash. Then we have repeatability. Repeatability. For repeatability to be established, the conditions must be in place: same location, same measurement procedure, same observer, same measuring instrument under same conditions, and repetition over a short period of time. So that means under all the locations being same, location को हम same रखते हैं, measurement का process same रखते हैं, observer भी same रखते हैं, measuring instrument भी same होगा. Under all these conditions, if I am repeating the value, or if I am repeating the measurements over a short period of time, is my instrument capable of giving me the same value? That is called repeatability. Okay, and it's known as the repeatability coefficient. It is actually a measurement of precision. हमने बात की थी that precision actually means how much you can repeat for the same values. जितनी बार आप repeat कर रहे हो measurement, your instrument should give you the same value under all these circumstances. Same location, same procedure, same observer, same instrument. When you're keeping all these conditions same, if it is giving you repeatable values, same value in repeated number of times, we call it a precise instrument, or you can also call it as a repeatable instrument. Then we have reproducibility. Reproducibility, on the other hand, refers to the degree of agreement between the results of experiments conducted by different individuals at different locations with different instruments. So reproducibility का मतलब होता है कि अगर हम अलग लोकेशन पर जाकर अलग डिवाइस के साथ सेम मेजरमेंट करते हैं, so do we get the same results or not? So reproducibility is more related to the phenomena. Okay, कहीं पर ग्रेविटी फोर्स अगर ज्यादा होगी, कोई फिनोमेना ग्रेविटेशनल फोर्स से अफेक्ट हो रहा है, कहीं पर ग्रेविटेशनल फोर्स डिफरेंट होगी, तो हमारी जो प्रोसेस है वो रिप्रोड्यूसिबल नहीं होगा. ठीक है, सो दिस इज लेस रिलेटेड टू द इंस्ट्रूमेंट, मोर रिलेटेड टू द process that actually you are trying to measure. Then we have linearity. It is defined as the ability of an instrument to produce its input linearly. Okay, so basically what we want to do is that the input and the output should follow a straight line relationship, or you can say a linear relationship. इसको समझने का बेस्ट तरीका होता है that you understand your input and output should follow the relation of y is equal to mx. अगर मैंने x input दिया तो output should be some multiple of x, suppose 2 multiplied by x or 3 multiplied by x, some constant m multiplied by x. That gives you a straight line relationship. In mathematics, if you remember, y is equal to mx is a straight line. So if your input and output, they follow that relationship, it is always called as linearity. That means your instrument is giving a linear relationship between the input and the output points. Then we have something called drift. Drift is a departure in the output of the instrument over a period of time. An instrument is said to have no drift if it produces same reading at different times for the same variation in the measured variable. Okay, so drift actually means over the period of time when you are using the instrument for some period of time, धीरे धीरे करके उसका जो पूरा ग्राफ है, जो मेजरिंग ग्राफ है, वो शिफ्ट हो जाता है. ओके, दैट मीन्स हो सकता है उसके अंदर कोई जीरो एरर आ जाए. जो रीडिंग पहले 0 से स्टार्ट हो रही थी, अब वो रीडिंग 0.5 से स्टार्ट हो रही है या 1 से स्टार्ट हो रही है. दिस हैपेंस ओवर द पीरियड ऑफ टाइम. ओके, जैसे जैसे उसमें वियर एंड टियर आने लगता है या ज्यादा स्ट्रेस डेवलप हो जाता है इंस्ट्रूमेंट में, तो क्या होता है, उसका पूरा का पूरा जो वो मेजरिंग ग्राफ है वो शिफ्ट होने लगता है. सो इट माइट बी दैट इट स्टार्ट्स इंट्रोड्यूसिंग सम जीरो एरर. जीरो एरर बोलते हैं that your initial value only doesn't start from 0, it starts from maybe 0.1, 0.2 or something like that. So that is called drift. Again, it is an unwanted phenomena. It gets incorporated due to wear and tear when your device gets old, or maybe some unwanted ambient temperature changes, something like that. That is what is actually causing a drift. Okay, so this is what we have talked about. Zero error, like I told you, that is what we can also call it as zero drift. Then we are going to talk about something called calibration. Now, calibration is the comparison between a known measurement and the measurement using your instrument. So calibration का सीधा सीधा मतलब होता है we have certain recognized primary standards, and calibration का मतलब होता है comparing your measuring device with that standard measuring device. So calibration actually happens in certain recognized laboratories which are recognized by the international agencies. वहां पर हमारे पास standards रखे होते हैं. Okay, for example, अगर एक scale भी है तो वहां पर एक scale रखा होगा which is considered as standard, जिसे हम मानते हैं this is 1 meter. So whenever we have to calibrate a meter of a meter scale of 1 meter, we always take it to the lab, compare it with that, and then calibrate your scale with the help of that primary scale. Okay, so it's a simple thing. We keep on hearing this word now and again. So calibration means, comparing it with the standard instrument, and it is very, very important to go on calibrating or recalibrating your instruments from time to time so that the accuracy can actually be maintained. Calibration की help से ही हम accuracy को judge कर पाते हैं whether the instrument is giving me an accurate reading or not. Okay, so that is what we explain calibration as.